Let's go to the problem of the day. A bag of 50 miniature candy bars sells for $3.50. It's a pretty good deal, it sounds like to me. While a bag of 70 miniature candy bars sell for $5. Could that be a better deal? Yes, we're going to find out. It says, which is the better deal? So we're looking at 50 miniature candy bars for $3.50, or that bag of 70 miniature candy bars selling for $5. Which is a better deal? And some of you are going like, who cares? It's candy, right? Well, let's figure this one out, all right? We got candy, candy, candy. Obviously, some of us might say, well, you're not going to try to give a lot for trick or treat. 70 might not do it, but 70 might be for some of you where you live, oh, way too much. You got some for yourself, right? And over here, the 50 for $3.50. Well, let's just check it out. You say, Ernie, how are we going to do that? Well, we're going to make a ratio. We're going to make a ratio here. We're going to take that cost, which is going to be, one of them is $3.50. And we're going to divide it up. We're going to make a ratio. That's what we mean when we make a ratio. It's rational. It makes a fraction, makes a division. We're going to put that 70 underneath there. Because this basically is saying, yeah, $3.50 per 70 miniature candy bars. Is that right? No. Ernie, tell me whoa. Tell me no. Tell me no. No, it's going to be 50, isn't it? We want to make sure we put our ratios in the right place. Okay, so that's the first thing. Make sure we're keeping it together. $3.50, 50. Now that you all been starting to think a little out there, how are we going to deal with the next one? There's only two numbers left, right? So let's keep the pattern going. Let's go with the $5 this time. I think that would be better because that's what the 70 pieces were going to cost us. So we're going to go with it. $3.50 divided by 50, which by the way will come out even. That's pretty nice, isn't it? This one, not so nice. Not so nice there. But we'll figure it out. We will take care of it and make it work. Or we'll make it do what it has to do, right? So let's take a look at this first little guy here. $3.50, divided by 50. As I said, that's pretty straightforward. It's almost mental math. I'm going to do it just for the fun of it here. Because we want to make sure we get that decimal point in the right place. Right now, it's sitting there between the 3 and the 5. It's not going to move. It's not going to move. But I'm going to tell you something about this. 50, it won't go into 30, that's for sure. It won't even go 35. So we're going to have to look at it going into 350, all right? Or in this case, 350. So let's put a 0 up there because it's not going to fly, but we've got to have that space for the decimal. Now, while we were thinking about it, we've got this 5 going into 35, and it's going to pop up 7 times. So here we go, 7 times 50, we get 350. We still got that decimal there, but we'll just put it there, we'll subtract. And look what's happening. We have nothing left. So decimal will go straight up. So this looks like 7/100ths. That's also known as, in money, 7 cents. So that's a 7 cents a candy bar. So there's our first side of things. Let's check out our second deal, all right? See which one's better. I hope everybody's voted out there by now, all right? Which way are you going to go? First or second? Which way? Let's see. We're going to take our 70. We will divide it into $5. Right there it is. And again, some of you say, well, could you use the calculator? Of course we could use the calculator. But on a problem like this, back in the, I guess elementary grades and even some middle school grades, you're still going to work this thing out and see what you get by hand. Long division, so to speak. Well, let's take a look at this one. It's kind of the same story setting up, isn't it? 70 won't go into 5, 70 won't go into 50. So we've got to go all the way to 500. Now think about it. Think about it with me here. How many times does 70 go into 50? Well, that's kind of crazy. How about let's talk about how many times 7 will go into 50. Forget about the other zeros. Let's just go with 70 into 50. No, 7 into 50, right? Going to take the little front end and this little part over here, just get an estimate. And if you look at, some of you saying, oh, could it go 8? Well, 8 times 7 gives us 56, too high. How about 7 then? 7 times 7, that sounds pretty good. Gives us 49. Didn't come out quite even, but that's okay. We'll see what happens. And by the way, where do we put that? Not into 50. Are y'all taking care of me out there? It's going to be over here again because we've got this situation. Remember, 70 doesn't go into 50, but 70 will go into 500. And it goes 7 times. We'll put that 0 right in there. Be careful when you put these numbers in place. Good old long division. And that can make a big difference. Right now, I've got a 10 there. I guess I can bring down one more 0. But look what's going on here. I'm going to bring that one more zero down. It looks like it's going to go one time, and then I've got 70, and this thing just looks like it's going to ramble on and on. Now, there's the decimal. So theoretically, they're very close. I mean, goodness, this is like, this is like 1/10 of a cent difference. Which we aren't quite that bad when we go out and buy gasoline, but we tend to go with, we have 1 penny difference. We'll drive across town and spend the money to get there, and 20 times over to save a cent or two on gasoline, getting to saying, well, I got a better deal. Well, in this case, I'd say they're pretty much the same. They're 7 cents each. This one is just a tad more. And I'll caution you, just because you're buying more for a certain amount of money doesn't necessarily mean you're getting the best deal. You've got to divide it and figure it out. You've got to see where it is. So this one, like I said, it's about 1/10 of a cent difference. If you're buying 1,000 or 10,000 things of candy, that is a price break probably. That will work there. But if you're just buying 70 or 50, you know, I just go with the deal here.